So this is becoming very popular. Of course, there's a cost premium associated with the product because it's all factory terminated, but if you look at the skill level required by the installers and the amount of time it takes to install and the fact that it is reusable, offsets that quite a lot in a lot of cases.
Do you offer some repair kits? Let's say if connector is broken, can you replace?
It is
can you splice whatever, cut it and splice to the new connector?
For the MPO trunk?
Yeah.
It's possible. I mean, there are field replaceable connectors. You'd have to look at what the cost difference is between actually buying the connector and being able to do it versus replacing the cable. If it's a cable that you can't replace, then yeah, it's something you want to think about. Well, it's either field replacing an MPO connector or splicing an MPO pigtail, which yeah, you can do either one. People still do this, and I don't know why. This is the field determination using the old archaic process where you've got an adhesive that requires heat curing. So you take the fiber, you clean it, you put it through the connector, and you put adhesive in there, and then you cure it, and then you got to cleave it, and then you got to polish it, you got to examine it, polish it again. It takes forever. The yield isn't great. The consistency of the end faces is based solely on the skill level of the technician. The only reason people do this is because these connectors are very cheap, and it may be what they're used to.
And they've done it for 1,000,000 years. So.
It just makes no sense to me anymore. There's so much better ways, right? I mean, if you've made your living as a fiber optic connector installer, and that's what you're making your bread and butter on, you may disagree with that, but there's just so many better ways to do it now. This being one of them. We've got what are called mechanical splice connectors. So here we have a field installable connector, but instead of having to do the glue and the cleave and the polish and everything, the factory end face is already polished. Okay, there's a fiber stub that exists in the body of the connector, right? And what you're going to do is you're going to cleave your fiber. You're going to mate those two fibers in a splice inside the body of the connector. You're going to crimp it, and there you have it. There's index matching gel in there that basically makes sure that the splice connection is good. The loss on these is very good. The yield is very good. The cost of the connectors is a little more expensive, obviously, than some of these other, the nap variety for sure. But the skill level required by the technicians to do that is much lower than this. So these are very popular.
So how do you ensure that your cable end is perpendicular and it will go?
You use a really good cleaver. You spend the money on the expensive cleaver and use it and rotate the wheel when you need to. It's all in the cleave. If you have a good quality cleaver, these things, the yield on them is great. 85, 90%, maybe more.
Our kit comes with an excellent cleaver.
I'm sorry?
Our kit, we have a kit that he's got one over there that comes with an excellent cleaver. He can show it to you after.
Yep. So the last piece here, and I appreciate your patience. I know we're pushing time here, but remember what you're dealing with here. Okay, it's glass, right? If you get it in your eye, it's not fun. If you get it under your skin, it's not fun. When you lose shards around the room and somebody finds them, they're not happy. Truthfully, right? And the other thing is that there is an eye hazard. Now with multi-mode, it's not as extreme. Okay, the light sources for multi-mode aren't quite as powerful. You can still hurt yourself with a VCSEL, particularly if you're pretty close to it. But the single mode lasers, the Fabry-Perot lasers that they use for single mode, you can damage your eye permanently. And you won't know it because you can't see the wavelength. Okay. Don't want to get laser corrective surgery that way. And as I mentioned, it's invisible light. You won't see it. Okay. All of a sudden you'll be driving home and you'll notice this dot that just won't go away, and you're like, what is that? Right? Well, you've burned your retina. There was a joke in the phone company for the fiber optic splicer guys. We'd say, hey man, don't look at that fiber with your good eye. Right? All right, you won't see it, but it will shoot your eye out. Okay. Yeah, exactly. So just be aware of whether or not you think there's light on the circuit. If you think there is, act like there is, and you won't be able to see it. So don't ruin your eye. And again, also you're dealing with glass here, so it's a really good idea to try to keep track of it when you're splicing or terminating or whatever.
Is there a device that you can stick on the end to see if you don't see the light, but there's something that will show that yes, there's light there?
Many different types, right? You can get a live fiber detector where actually what it will do is you can clip it on a fiber like a patch cord, and it will put a bend in it, and it try to cause a macro bend to see if light comes out. Okay. You can also, there's a card that has a phosphorescent substance on it where if you hold it up to a fiber, if it glows, then it's got light on it. right? There's meters and all kinds of stuff. So there's a lot of ways you can tell.
Can you see this wavelength on your camera's display? If you shoot
You know, I saw something really interesting about that.
Because we can test infra remotes. When you look at it, you can see the emitter blinking, but I don't know the exact wavelength.
I remember
on
seeing
that.
something on YouTube about that. I'll look that up. That's an interesting
Maybe we
point,
should
though.
try it out.
It's an interesting point. We don't have any light sources here, but
Oh, okay.
no, I did hear something where with your cell phone camera, you should actually be able to tell whether or not there's someone there.
Can we take the server down?
That's okay with me. Hey, where's Justin? Let's ask Jessie. She'll let us know.